total surface area of a prism. So what is total surface area? Total surface area is the area of all of the faces on a prism. So here's my prism over here, and this is a rectangular prism. It has 6 faces. So faces are the shapes on the prism on the outside. So here's what we've got: 1, 2, 3. That's the same as the first one. 4, 5, 6 faces. The first thing you're going to need to do when you're finding the total surface area is to draw this 3D prism, draw the faces of it in 2 dimensions. So on your flat surface on your book. So to do that, we're not drawing a 3D picture, we're drawing a 2D net. So this is really backfiring on me. Looks like I've just wrecked my prism a little bit, but anyway. Here is the... It's got holes in it, just ignore the holes. Here's the net. So this is the 2-dimensional version of it, of the prism. And you can see that all the 6 faces are here. You can also see they join up in all the same places. And so a lot of the time people draw nets and they draw the biggest face. They start off with the biggest face and they draw that, and then they draw the other ones around it. And then once you've done that, you'll have 5 faces, and you'll realize you have to stick the 6th face on there somewhere. So that's over here. Now if you have a triangular prism, there are less faces. In this one, here's the triangular prism. And if I unfold it, then I get the net. And again, you've got a big face over here. And next to that face, you can draw all the other faces coming out of it. Okay, here is a different example, the cylinder, and we'll come back to the cylinder in the later part of the video. Alright, so we've covered a couple of things already. We've covered what are the faces of a prism, and we've kind of talked about what nets are, but in the next few examples we'll talk about drawing nets and the total surface area of prisms. Okay, so here's one example of a prism that we can find the total surface area of. So remember, we took one of the faces and we chose the biggest face. So let's do the same thing here. The 8 centimeters by 5 centimeters face. And we said it might be a good idea to draw all of the faces that are attached to that. So let's do that. So on this side, we've got another face over here. On this side of the rectangle, we've got another face over here. And the width of both of these faces is 3 centimeters. And so we've got another one attached to the bottom. And the top. And finally, we have to draw this top face somewhere. Doesn't matter, as long as it's attached to the right. It could be attached to here or here. So let's draw it attached to this face that we just drew. Okay. And we've drawn some dimensions on there. But the dimensions of this one and this one are the same. So these are 2 identical faces. And these are 2 identical faces. And these 2 are identical as well. So really, if we want to find the total surface area, we can find the area of one face, like this one, this one, and we can times it by 2 so that we get both of the faces. So 2 times, this one's 8 times 5. So the area of a rectangle is the length, so the base times the height, which is 8 times 5. So now we've got this face and this face. Let's add on the area of these ones. So this would be 3 times 5, and this one's the same, 3 times 5. So we'll times that by 2. Now we've got, because we've times it by 2, we've got both this face and this face. And the final ones, let's do this one. It's 8 times 3, and we'll times it by 2 so we get both of them. Okay, so that's equal to 2 times 40 plus 2 times 15 plus 2 times 24, which is 80 plus 30 plus 48. Finally, that is 158, if I'm not wrong, centimeters squared. Keep in mind it's area, not length, not volume, so it's centimeters squared. Okay, let's do a triangular prism. So we'll start off by, we can draw the bottom face. Keep in mind that's not the base. The base is the triangle. The base is always the shape that's being stretched out. But let's draw this bottom rectangle just because it's a big face that we can draw all the other faces around. And we can draw the triangle here, the other triangle here, and we've got this rectangle over here and this one over here to draw. So let's just start off with, we might as well label our first face, 4 centimeters, 12 centimeters, and we'll label the triangle down here. That's 7 and 6, and 7 and 6 centimeters. All right, now this rectangle over here, one of the sides is 12, one of the sides is 6. And so we'll draw that. This other rectangle over here, one of the sides is 12, one of the sides is 7. So just be careful with these triangular prisms. Sometimes people assume that these two rectangles are the same, this one and this one. But if these two lengths are the same, are different, then these two rectangles have to be different, otherwise it's not going to fit together. So, okay, so this has to be 7 centimeters. All right, so how many different shapes do we have? The only two shapes that are the same are the triangles. So let's start off with the triangles. Total surface area equals, because they're the same, we'll write 2, there's 2 of them, times, and then we'll work out the area of this one. So the area of a triangle, keep in mind, is a half times base times height. What's the base of the triangle? It's 4 centimeters. What's the height? It's not 7, it's 6 centimeters. Now, when we're adding on the rectangles, we can't do 2 times anything else because all of these are different. So we have to do them one by one. We'll start off with the first one we drew, 4 times 12. Then we'll move on to this one. It's got a height of 6 and a base of 12. So 6 times 12. And this one, finally, the height is 7. So it's 7 times 12. And then adding that all up, that just, don't worry, I'll just go quickly here because you don't want to be here forever. We've got 24 plus, if I can go quickly, 48 plus 72 plus 84. Oh, all right. Adding up the tens, we've got 60, 130, 210. Adding up these, we've got 12, 14, 18. So we've got 228. Sorry, I said we'd go quickly and then I went very slowly. I would do this on a calculator. My concern really is that you understand how to do this, not that you can do this in your head. That's not important. Okay, now let's draw our net for this one. So we'll just draw the shape and then we'll get into what the distances all are. Okay, it looks like I've drawn a square here, but it's not necessarily a square. So the height of this, where's the height? What are we actually looking at here? If I roll this up, it will look like this cylinder over here, and we won't need to rotate it or anything. So this one is the height, that's 15. I've got a radius of 4. Now, in order to find the area of this rectangle, we have to know this side over here. But remember, in the previous section, I showed you with the net that this length here is the same as the circumference of the circle. So this length here has to be 2 times pi times r, which is 2 times pi, the same circle, so they have the same radius, times 4 centimeters. And let's use a calculator to find that out. We've got 2 times pi times 4. That's 25.13 roughly. I'll include enough decimal places so that it's pretty accurate. And then we'll keep going. So now I can get rid of this question mark. Oh, no, I can't. 25.13. All right, now total surface area now gets a lot easier. Let's do the circles first. 2 times, we have to have the area of the circle, which is pi r squared, plus the area of the rectangle, which is 25.13 times 15. Now, what's r? R is 4, so we've got 2 times pi times 4 squared plus 25.13 times 15. And I'm going to try and remember that. We'll see. So we had 2 times pi times 4 squared plus 23, already forgetting, 25.13 times 15. And we've got 477.48. Okay. Now, it's probably not going to be very accurate, so let's just round it off. We'll be safer that way. 477 centimeters squared. Alright, I had one other example, this one, but I'm going to make another video out of that because this video is really too long. So I will see you in that video.